locus of a system. So let's see what is the problem. So our problem is to sketch the root locus with k as a variable parameter of a unity feedback system whose open loop transfer function is given to us, and it is gs equals to k s plus 1 upon s square. So let's solve this problem. So to sketch the root locus, first we have to find out the open loop poles and zeros of this system. So our first step will be we have to find out the open loop poles and zeros. So to find out the poles, we have to equate this denominator term to 0. So s square equals to 0. So we have two poles at the origin. Okay, that is s equals to 0 and s equals to 0. These are the two poles. Now to find out the zeros, we have to equate the numerator polynomial to 0. So s plus 1 equals to 0 and it will be equals to s equals to minus 1. So s equals to minus 1 is our 1 0 and s equals to 0. These are the two poles. So these are the two poles and this is our 1 0. Now our second step will be to find out the starting and the ending point of the root locus. So the root locus, it starts from the zeros and it starts from the poles and it terminates at the zeros. So our second step will be the starting and the ending point. So the root locus as it starts from the poles and terminates at the zeros. So the starting point will be the two poles s equals to 0 and s equals to 0. These are the starting points, and the ending points will be s equals to minus 1, that is the 0, and k equals to infinity. Okay, one pole will one root locus, it will start from the pole s equals to 0 and terminates at s equals to minus 1, and another branch of the root locus, it will start from s equals to 0 and terminates at k equals to infinity. Now third step is we will plot the poles and zeros on the s plane. This is our S plane and this is the imaginary axis and it is the real axis. Okay, and this is our origin. So on origin we are having two poles. Okay, so we will denote it by double cross, because we poles, they are denoted by a cross sign and zeros, they are denoted by a circle. Okay, so on origin we are having two poles and on s equals to minus 1 we are having 1 0. Okay, so this is s equals to minus 1 and this is s equals to 0, or we can say k equals to 0 and this is k equals to infinity. Okay, so there are two branches because we are having two poles, so the number of poles is equals to the number of branches. Number of branches of root locus is equals to number of poles. So there are two poles, so there will be two branches of the root locus. Now let us determine the direction of the root locus. If we take a point here, then the number of poles and zeros on the right hand side of this point are 1, 2, 3. So it's an odd. So for this 0, the direction of the root locus will be in this side. That is okay. Now for one pole, if we take this point here, then the number of poles and zeros on the right hand side will be 2 for both these poles. So the direction of root locus will be in this side. Now this will start from the pole, but it is terminating at infinity. So it has to come in this direction, somewhat like this. For one pole, and this is for second pole, and it will start from here and terminate at the pole at the 0 s equals to -1. So we have got the direction of the root locus. Now our fourth step, so our next step, that is step number 3, it will be to find out the breakaway point. We have to find out here the breakaway point because we are having two poles and the direction of the branches of the root locus from these two poles, it is crossing each other. They are coinciding. The direction of the root locus from this pole and this pole, it is coinciding at one point. So we have to find out this breakaway point. And to find out this breakaway point, we have to differentiate the open loop transfer function, that is differentiation of GS with respect to S, and then equate it to 0. Okay. So our GS is given to us in the question as KS plus 1 upon S square. So differentiate this expression with respect to S and then equate it to 0. Differentiation of GS will be dgs by ds. It is k s plus 1. Differentiation of s square will be 2s minus k. Differentiation of s plus 1, it will be 1 and then s square divided by s to the power 4. So it is the differentiation of GS with respect to S. Now equate this to 0 and get the value of S. From here we were having 2s square k plus 2sk minus ks square upon s to the power 4 equals to 0. Now this s to the power 4, when it goes to the right hand side, it will become 0. And this is 2s square k minus ks square, so it will be ks square plus 2sk equals to 0. Take k common, so it is s square plus 2s equals to 0. When k it goes to the right hand side, it will be 0, and then we have s square plus 2s equals to 0. Take s common and solve this, we will get s equals to -2. So our breakaway point is s equals to -2. Okay, that is the two branches of the root locus. They are coinciding at s equals to -2. Now step number 4. Step number 4 is to find out the asymptotes. First, we will find out the intersection point of the asymptotes with the real axis. Okay. So our first is to find out the intersection point. The formula for finding this is x equals to summation of p minus summation of z upon p minus z. Summation of p, it is the sum of all the poles of the system. Summation of z means sum of all the zeros of the system, and p is the number of poles and z is the number of zeros. So let us find out this. We have poles 0 and 0, that is two poles s equals to 0 and s equals to 0. So their sum will be 0 plus 0 minus summation of 0. We have 1 0 s equals to minus 1. Putting its value here. This is the summation of p minus summation of z. Now number of poles, there are 2 poles, and number of zeros, there is 1 0. So this is 2 minus 1. So our x will be, this is 0 plus 1, 1 upon 1. So we are having x equals to 1. So the asymptote, it will intersect the real axis at x equals to 1. Now second step is to find the angle of the asymptotes. To find out the angle, we have the formula as theta equals to 2m plus 1 into 180 degrees divided by p minus z. Here the value of m is, it can be 0, 1 and it is up till p minus z minus 1. P is again the number of poles and z is again the number of zeros. So p is what? 2 poles and z is 1, 0 and minus 1. So it comes out to be 0. So m is going to have only one value, that is m equals to 0. So for this n equals to 0, we will find out theta, putting the value of n here. 2 into 0, it will be 0 plus 1 into 180 degree, and p minus z, that is 2 minus 1. So we will get the value of theta as 180 degree. So we are having only one asymptote, and the angle of that asymptote is 180 degrees. So we have got all the values, we have performed all, we have got all the steps. Now we will draw the root locus. This is the imaginary axis. This is real axis. We are having 2 poles here, and we are having 1 0 at s equals to minus 1. This is s equals to minus 2, and s equals to minus 2 is the breakaway point. Now the direction of the root locus, it was like this. It will start from this pole, comes at this breakaway point, and it will goes in this direction, that is k equals to infinity. This is what k equals to 0, and we have 2 poles here, s equals to 0 and s equals to 0. Its direction will be like this, starting from the pole and terminating at infinity. Again, we have another branch, it will come here, start from the pole, terminates at this point. Okay. So this is the complete root locus of this system. We have drawn all the things, like pole we have denoted here by cross, we have denoted the 0 by circle, and this is the complete root locus. S equals to minus 2, it is the breakaway point. and we are having the asymptote at theta equals to 180 degree. So in this problem, we have sketched the root locus of a system having the open loop transfer function Gs as k s plus 1 upon s square. I hope this problem is clear to you. Thank you.